Hello and welcome to Casio's online course for the new and improved Color ClassPad. In this session we will be taking a closer look at the NumSolve or Numeric Solver application. If you're at the main icon menu on your ClassPad, if you tap and drag to the next screen, you should see NumSolve available with the orange icon reading AX equals B. Tapping on that brings us into the Numeric Solver. It's a pretty simple interface. There's not a lot to it. We can enter our equation, and you enter an equation in however many variables, provided that there's a single unknown only. So a good initial equation to play around with would be, let's say, a conversion from Celsius to Fahrenheit. To do that, I'm going to need my keyboard. I'm going to go to my letters, ABCs, and I'll pull up C for Celsius equals, let's go back and grab a fraction, 5/9, parentheses, F minus 32. And when I finish that up and press execute, the calculator will go through, identify any variables it sees, and now all I need to do is tell it what either of those is, then it can solve for the unknown. For example, what if we have 100 degrees Fahrenheit? I just enter 100, press execute, make sure the radio button next to C is selected and press solve. And it determines that it's approximately 37.8 degrees Celsius is 100 degrees Fahrenheit. Now if I want to compute the other way around, I can just tap on that number next to Celsius, put in a number, let's say 100 degrees Celsius, make sure the radio button next to F is now highlighted, so I'll solve for F, and when we press solve, sure enough we get 212 degrees Fahrenheit, which should look familiar to those of you who use Fahrenheit. So it's pretty much that. Any equation you can think of, this should work for. It does a numeric approximation, so it won't always be an exact perfect answer, but this is a tool that has a specific purpose if you just want a quick decimal approximation. That said, let's try another example just to illustrate a few other of the details you should be aware of. Let us compute the height of an object equals -1/2, and we'll say, the force of gravity times time squared plus initial velocity times time. It's very important that you enter that multiplication. If I were to just type VT, there is nothing that helps the calculator distinguish between V times T and VT as a single variable name. It's a benefit to be able to name variables with more than a single letter, but then the calculator must be more cautious, and it can't assume you want to multiply here. So if you do want to multiply, be sure to put in that multiplication symbol. The only exception is if I back up to the variable tab, anything in bold italics is assumed to be a single variable, not a name, not a multi-letter name. And so these you can actually put next to each other without a multiplication symbol. But these standard letters require a multiplication symbol. When I enter my function and I press execute, it converts it so it looks just a little more attractive. It identifies the variables, and now all we need to do is tell it what we know. So if, for instance, the force of gravity is -32 feet per second squared, I'm not going to put a negative since there's already a negative built into my equation. And let's say my initial velocity is 60 feet per second, and perhaps I want to know the height of an object after 5 seconds. So I highlight the radio button, press solve, and it would be -100 feet. So it would have flown in the air, dropped to the ground level, and if possible, fallen 100 feet farther below ground level. What if we maybe try a little closer in? Let's say a time of 2 seconds. Again, if we solve this, now we're 56 feet in the air. So that's one way you can use it. You can just keep trying a bunch of different times. However, what if we want to know when the height is 6 feet off the ground. So now I'll put a 6 in here. And if I want to know when, I'm trying to compute time. So I need to put the radio button there, and I press solve. And so we know that the ball reaches 6 feet at 3.65 seconds, approximately. However, if that's the case, we expect the ball to reach 6 feet on the way up and on the way down. So I'm not sure if this is on the way up or on the way down. Let's try to get a different result. We expect two potential results with a quadratic. And this is where the lower and upper bound come in. If I force the upper bound to be below this 3.6, let's say at 2, and I recompute, now we get a different time, 0.103 seconds. So you see what's happening is these boundaries are somewhat helpful, because if you have multiple results, the calculator doesn't know to keep looking for them, and you can help it by putting in these boundaries. Likewise, you can also just put in a value for t, and then it will try to find, I think I maybe busted it by putting in a boundary. But another option, if you leave the boundaries alone, you grab that. It's not wanting to let me drag. So 9. I wonder if I leave it blank. Let's try that again. Nope, it's keeping it at 2. So I would have to type it in 9, and let's see where I can find, oh, I guess it's right here. We can just use that. E999. Execute. So now, if I change my t value when I solve, it will find the value closest to t, whereas I can use the lower and upper bound to only search a specific region. Lastly, let's solve another equation. Let me clear this, edit clear all, and let's solve y equals x squared minus 4x minus 45. So what if y is 0? What would x be? We solve, we get -5. I want another result, so I'm going to guess that I want something larger than -5. So let my lower bound be -4. Solve again, and 9. -5 and 9 are my two results. Okay. Now look what happens when I go to the main computation and I look at what's stored in x. X is now 9. That is not a coincidence. If we go back to numsolve, you'll see that x was 9. Not a coincidence at all. So in main, if I were to take x and let's say I store 25, go to the keyboard and store 25 into x. Okay. Now we go back to numsolve, and look, x is 25. So one of the strengths and weaknesses of this calculator, just something you need to be aware of, because it's just the way it acts, is that all these variables are connected. So that can be good and bad. It's good if you get a result here and you want to go and use it in main. It's very easy. It's bad if you're not aware of it and you change something in one place and you break something you have set up in another location. So just really important that you understand that those variables are connected. If you ever want to reset them, we can clear A to Z. That's only variables titled A through Z, or any programs titled A to Z. Likewise, if you want to reset these boundaries, you just click Initialize Boundary here, and it will put them back to the way they were. That said, thank you for checking out this session, and I hope you enjoyed it, and I hope you get a chance to check out our other videos. Thanks a lot.